I didn't figure out what to do with that database yet, but actually here, let's just spend 10 minutes right now trying to figure out what to do with it. So if I think about it, right, you would have, if we did something simple, you would have some sort of index, right? Like some sort of SS table, and then, well, no, even before that, I think what you would do is you would write to a file. Should we do like compaction and merging? Might be interesting. It doesn't seem like it's that crazy initially. But I think it's more of how do you do it when it's distributed. So let's see, at a base level, what does it do, right? Huh. Um, hmm. So I feel like what I could probably try and do is for the next time is I could probably add in some sort of index. No, not index. Start writing segment files. We'll just make it append only. And then, yeah, we'll just make it append only. And then we'll start by compacting. And then we can merge. At a fundamental level, I know the goal of compaction. So if it's an append-only log, I only ever have to append, right? And then the goal with compaction would be after a certain amount of time, or after a certain size, we need to start removing the unused keys, right? Because we only take the last one. And then for merging, I guess we'll have segment files. We'll have a max segment file, max length segment file, and then we'll start merging eligible ones. I don't know if that's gonna be feasible. Like, can I do this in a few weeks? Probably not. Maybe this was kind of a fool's errand. I got a little too ambitious, maybe. Because it's like, if I'm gonna continue with this book, probably shouldn't spend the entire time just looking at that stuff. I don't know. Let's see. The writer schema and the reader schema. Okay. I feel like I just sat here for almost 10 minutes and I didn't actually come to any conclusions. I just don't know what to do. Let's actually just spend a few more minutes, look at something again, and just see. Oh, it's a video, that's why I haven't. Hmm. Alright, let's just keep going for now. I'll just have to figure this out at a different time. Okay. With avro, version of the schema is writer, old version of the schema is reader. To maintain compatibility, you may only add or remove a field that has a default value. The field favorite number in our avro schema has. Say you add a field with a default value, so this new field exists in the new schema, but not the old one. When a reader using the new schema reads a record written with the old schema, the default value is filled in for the missing field. If you were to add a field that has no default value, new readers wouldn't be able to read data written by old writers. Can we explain that? So default values help with compatibility so that new readers can read old values because they can fill in that value if it's missing with the default value. If you were to remove a field that has no default value, old readers wouldn't be able to read data written by new writers, so you would break forward compatibility. Let's try something. That's not what I want to do, but let's see. Add. What? We come back here, and then add. I go screen capture, preview. Nice. And then open preview. Let's make this reasonable. I don't know why it zoomed in so much. Oh, it's just because it's monstrous. I see. Let's do this. Fix this. Me up. Hiccups. Okay, so I'm here reading through avro. I'm here. Okay, what I want to try. So we'll do key ideas in pink. With avro, forward compatibility means that you have a new version of the schema as writer and an old also, like, this is pretty clutch. Conversely, backwards compatibility means that you have a new version of the schema as reader and an old version as writer. Okay? And then forward compatibility means that you have a new version of the schema as writer and an old version of the schema as reader. Okay? This is also clutch. In some programming languages, null is an acceptable default value for any variable, but this is not the case in avro. If you want to allow a field field to be null, you have to use a union type. So let's see here. What's going on here? If you were at a field that has no default value, new readers wouldn't be able to read data written by old writers, so you would break backward compatibility. If you were to remove a field that has no default value, okay, I've read this. In some programming languages, null is an acceptable default for any variable, but this is not the case in avro. If you want to allow a field to be null, you have to use a union type, for example, null long string. Indicates that field can be a number or a string or null. You can only use null as a default value if it is one of the branches of a union. See, this is avro specific. I don't care about this. This is a little bit more verbose than having everything nullable by default, but it helps, okay? Consequently, avro doesn't have optional or required markers as the same way as protocol buffers do. Changing the data type of a field is possible, provided that avro can convert the type. Okay, so number to string would probably work. Changing the name of a field is possible, but a little tricky. The reader schema can contain aliases for field names, so it can match an old writer schema field names against the aliases. This means that changing a field name is backwards compatible, but not forward compatible. Adding a branch to a union type is backwards compatible, but not forward compatible. Two processes are communicating over a bidirectional network connection. They can negotiate the schema version on connection setup, then use that schema for the lifetime of the connection. Okay. So for avro, let's see if I can remember it. Forward means the writer is new, but the old reader still works. Backwards compatibility means the reader still works, the writer can't. Yeah. Type. Okay, and then what was the next section? So how do I spell retrieve? Oh my gosh, I have to Google this. That's so embarrassing. Retrieve. IEVE, yeah. Am I crazy? I'm not understanding why this would be better. If you use avro, you can fairly easily generate an avro schema from the relational schema and encode the database contents using that schema. Okay, dumping it all to an avro object container file. You generate a record schema for each database table, and each column becomes a field in that record. The column name in the database maps to the field name in avro. Okay, that part I understand. Now if the database schema changes, for example, a table has one column added and one column removed, you can just generate a new avro schema from the updated database schema and export data in the new avro schema. So we dump the old one, we generate a new one. Okay, the data export process does not need to pay attention to this. Does not need to pay attention to the schema change. It can simply do the schema conversion every time it runs. Anyone who reads the new data files will see that the fields of the records have changed, but since the fields are identified by name, the updated writer's schema can still be matched up with the old reader's schema. I'm not sure I really understand this. By contrast, if you're using thrift or protocol buffers for this purpose, the field tags would likely have to be assigned by hand. Not sure I really understand it. Code generation in dynamically typed languages. Dated. I don't know. All right, let's move on. I'm not sure. I'm not sure. Dude, I am like zoning out so hard. uh, like it's so slow to read out loud, but I cannot focus. Many data systems also implement some kind of proprietary binary encoding for their data. For example, most relational databases have a network protocol over which you can send queries to the database and get back responses. Yeah, those protocols are generally specific to a particular database, and the database vendor provides a driver that decodes responses from the database's network protocol into in-memory data structures. Oh yeah, interesting. So we can see that although textual data formats such as JSON, XML, and CSV are widespread, binary encodings based on schemas are also a viable option. They have a number of nice properties. You can be much more compact than various binary JSON variants, since they can emit field names from the encoded data. The schema is a valuable form of documentation. And because the schema is required for decoding, you can be sure that it is up to date, whereas manually maintained documentation may easily diverge from reality. Keeping a database of schemas allows you to check forward and backwards compatibility of schema changes before anything is deployed. For users of statically typed programming languages, the ability to generate code from the schema is useful since it enables type checking at compile time. Y'all, this sounds great. What are we talking about? Schemas are sick. I get it now. I think I can see the bigger picture here. So it's formats of encoding data. We did JSON, XML, and binary. Then we did binary encoding. And then we went to avro and schemas. Okay. All right. And then what's the next? Modes. All right. Good enough for today. Not super directed, but we're still making progress. Cool.